Good morning, my YouTube viewers. In this particular video, what we're going to be talking about is statistical experimental design, and in particular, we're going to be talking about factorial design. And factorial design tests multiple factors simultaneously by creating combination of all factor levels. It is ideal for exploring interactions between factors, such as the effect of fertilizer type and irrigation frequency in agriculture. So what we're going to do is we're going to do a practice question, and we're going to write a computer program in Python to answer that practice question. So the practice question is, a manufacturing company is testing the durability of a new product. They want to evaluate the impact of two factors: temperature, low, medium, and high, and pressure, low and high. And so we're going to design a factorial experiment to assess the main effects of the interactions of these factors on product durability. So we're going to write a program in Python. And so the first thing that we're going to do is we're going to import the libraries that we're going to need to execute the program. So the first library that we're going to need is NumPy as NP, which is a numeric library that also creates NumPy arrays. And then we're going to import pandas as MPD, and that's pandas is a data processing library that also creates data frames in series. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And from itertools, we're going to import product. So itertools is just a library that helps with iterations, and product is going to be the function that it's going to use in itertools. And then from scipy.stats, we're going to import F1way. So scipy is Python's scientific library, and stats is a statistical module within scipy. And F1way is going to be an ANOVA test that we're going to use in the program. And then what we're going to do is we're going to simulate the factorial experiment. The first thing that we're going to do is we're going to set the seed. And you need to set the seed because every time you run the program, it initializes the variables to the same values. And so that's why you set your seed. And you set your seed by typing np.random.seed and any number that you want within the brackets. Now we're going to define the factors and the levels. Temperatures is a list of low, medium, high, and pressure is a list of low and high. So we're going to create all combinations of factors, which is what they call factorial design. So SCR combinations equals list, product, brackets, temperatures, pressure. And product is what we're using in the function that we're using in itertools. So we're going to simulate durability, e.g. hours, for each combination. So data is going to be an empty list for temp, pressure, and combinations. And then base durability equals 100. Temperature effect is a dictionary as low equals 10, medium equals 0, high equals -15, and that's the temp. And pressure effect equals a dictionary of low is 5 and high is -10, and that's your pressure. And so variability equals np.random.normal, brackets 0, 5, 10. And so basically what that is a normal distribution that has a mean of 0, a standard deviation of 5, and a sample of 10. And now we have durability values equals base durability plus temperature effect plus pressure effect plus variability. And then so for value and durability values, data.append temp pressure value. So now we're going to create the data frame now that we've simulated all this data. So df equals pd dot data frame brackets data, comma, columns equals a list of temperature, comma, pressure, comma, durability. And so the first column, column 0, is temperature. The second column, column pressure, or column 1 is pressure. And the third column, column 2, is durability. Because you have to remember that in Python, the first number starts with 0. So we're going to calculate the mean durability for each combination. Summary equals df.groupby, brackets, temperature, column, comma, pressure, square brackets, durability, dot mean, dot unstack. And then so we're going to print the summary statistics as mean durability by temperature and pressure. So mean durability by temperature and pressure, you've got your pressure, which is high and low, and you've got your temperature, which is high, low, medium. And so it gives you the values for the pressure at high, low, medium values. So now we're going to go back to the code. So what we're going to do is we're going to perform an ANOVA, and an ANOVA is an analysis of variance to assess the main and interaction effects. So ANOVA results temperature equals F one way, and it's df brackets temperature is equal to low square brackets durability, comma, df square brackets df temperature is equal to medium square brackets durability, comma, and df square brackets df temperature is equal to high durability. And then the ANOVA results for the pressure is df pressure is equal to low brackets durability, and df pressure is equal to high brackets durability. And then what we're going to do is we're going to print the ANOVA results for the temperature and also the pressure, being the F statistics. So being the F statistics and the p-value. So we go back to the bottom of the cell, and the ANOVA results for the temperature, the F statistic is 32.294, the p-value is 0, and the F statistic for the pressure is 33.182, and the p-value is 0. So that means that since the p-value is less than 0.05, that means that there's a significant difference between the values of the temperature and the pressures, and so that means that the null hypothesis is going to be rejected and the alternate hypothesis will be accepted, because the null hypothesis means that there's no significant difference between the values, and then there is a significant difference between the values. So it doesn't, in this particular code, it just wants you to print your results, but it doesn't actually test for the p-value. But I'm telling you that the p-value, if it is less than 0.05, then the null hypothesis is rejected and the alternate hypothesis is accepted. And the null hypothesis means there's no significant difference between the values, and the alternate hypothesis means there is a significant difference between the values. So we're going to visualize the data. So we're going to make a bar plot of mean durability, plt.figure, brackets, fig size equals 6, 4, summary.plot, brackets, kind equals bar. That means you're going to get a bar chart, comma, figure equals 6, 4, comma, alpha equals 0.8, comma, color math equals viridis. So now we're going to customize the plot. The title is Durability by Temperature and Pressure. Y label is mean durability hours. X label is temperature. X ticks equals rotation equals 0. So if you want to change that, you can make it rotation equals 45. And sometimes I do make it rotation equals 45. You get a legend. Its title is pressure. And then the grid is axis equals y, comma, line style equals dash, comma, alpha equals 0.7. So you're going to show the plot is type layout and plt.show. So you're going to this durability of temperature and pressure. So purple is high pressure and yellow is low pressure. So high temperature, medium temperature, low temperature, and you can see that there is a significant difference between the temperatures, between the pressure, between high, low, and medium temperatures. So that concludes this particular video. The next video is going to be another one on experimental design, so I hope that you decide to watch it.